So in this module 1, we are discussing on memory units. So we all know that this memory unit is being useful for us in storing the programs as well as storing the data. And we all know that this memory unit is of two types, which is primary storage memory as well as secondary storage memory. In case of primary storage memory, we call it as what? The main memory. It's the fastest memory. It's been useful for storing the programs and active data. Alright, the main memory is the secondary semiconductor memory, which is the main memory, which is indirectly a primary memory, which is semiconductor memory, which will consist of a larger number of semiconductor storage cells. Each of them are capable of storing one bit of information, and these cells can be read or can be written by using central processing unit in a group of fixed size called as word. And the main memory is organized in a way that all the components of one word will be containing the bits which can be stored or retrieved in one write or read operation. It can be one write or it can be one read operation. And if you look at this memory unit, the addresses are consecutive numbers starting from 0. Let us say we have a block of data. In that block of data, we are able to have the numbers starting from either 0 and that indefinitely to the successive locations, which means from 0 it will go up to 1, 2, 3, 4, n number. And in particular, the word is accessed by specifying its address and issuing a control command to the memory that starts the storage or retrieval process. So this is how the memory unit is going to function in an effective manner. And we also know that the memory where it was located, it also can be accessed in a short as well as fixed amount of time. It can be accessed in short time or it can be accessed in fixed amount of time. That is called as what? Random access memory. The time what we require to access one word is called as memory access time, which means one word of data if you want to access, how much time we are going to consume, that is called as memory access time. So this memory access time, it will vary. It will vary from what to what? It will vary from few nanoseconds to around 100 nanoseconds. In the modern computing units, it will vary from a few nanoseconds to around 100 nanoseconds. So this is how the memory access time can be varied from these ranges. And usually this memory can be implemented as a memory hierarchy. So memory hierarchy means what? Which means we can have around 3 to 4 levels of RAM units with different speeds and sizes. So we will have a different types of RAMs and different types of RAM with different speeds. Size will vary as well as subsequently the speed also will vary. And the small and fast RAM units are called cache. If it is smaller and it is faster, that corresponding RAM unit is called as cache, and that corresponding memory is called as cache memory. So this cache memory is completely tightly coupled with the help of a processor, and this also will contain same chip to achieve high performance. The cache memory will be in a form of the same chip so that we can able to achieve the better performance. All right, and largest and slowest units is referred to as main memory, which are slower or which are larger. So those things we call it as what? Main memory. So which is smaller and faster, it's cache, which is larger and slower is called as main memory. We'll conclude this memory. So whether we have a primary memory or secondary memory, which will tend us to the expensive and does not retain information when power is turned off. So let us focus more on primary memory. So as this primary memory, when we turn off the power, we cannot able to store the data into it. Whereas in case of secondary memory, uh, we're going to use a larger amount of data, and that too it will be a slower way it's been working, because it has a lot of programs to be stored. So in that manner, we can able to say that it has been slower, and we are trying to access the information uh, in an improper manner, or we are not accessing it frequently, then the access time for secondary storage are longer than primary memory. If you are accessing it properly, it will be fine. When we are not accessing it properly, the storage time, or let us say the access time, will be much more larger than in case of primary memory. What are the examples of this secondary memory? The magnetic disks, optical disks like DVD, CD, and flash memory devices. So all these are examples of secondary storage unit. And in the next session, we'll see on arithmetical and logical unit. So what is ALU? First of all, ALU means arithmetic and logical unit, which the name itself is going to indicate that it's going to process the arithmetical part as well as the logical part. So arithmetical part means what? It is like performing addition, subtraction, multiplication, and division, and so on. And what about logical part? Any idea? So this logical part is indicated uh, to bring up logical and logical or negate, all that kind. So this will be performed by using ALU, so arithmetic and logical unit. Let us say an example. Let us see an example for the ALU. We have two numbers with us, which were located in memory. Uh, we have to add them. We have two numbers in a memory. We need to add the two numbers. How do we add them? Who is going to help us in adding them? Undoubtedly, yes, the processor is going to help for us. How this processor will be helpful for us? This process will be carried out by using the ALU. The processor is able to do the task. It's going to sum up these two numbers and store them back in the memory, such that it can able to retain, and we can able to use the value immediately. So these kind of things will happen in ALU. And take the next point. When we have operands which are brought into the processor, and they are stored in high speed storage elements called registers. So all these operands are brought into the processor when we try to bring them into the processor. So these operands are stored in a high speed storage, which we call that as what? Registers. And this each of the register what we use here can store one word of data. Each register can store at least one word of data, and the time required to access it is even shorter than required the access time to that of cache unit on the processor chip. So let us continue this session uh, with output unit. So we all know that, so where the result is going to get displayed, that can be called as an output unit. So what's the example for the output unit? The printer is an example of output unit. So we have some units such as like graphics display, and output functionality block, text and graphics block, input functionality block, touchscreen capability. All these blocks are called as an output units. So we have something called control unit. The main ALU and the IO units will be stored, and that information will be performed with the help of IO operations. And these control units will able to coordinate the operation with the different units of the computer, which means one computer has to communicate to other computer. This IO device will be taken care by the control unit, which input block has to be controlled by which memory. So all that details will be taken care by the control unit. IO transfers, what will happen, we're going to control this by using input or output operations. So we have to make sure that the data transfer between the processor and the memory happens appropriately, and the data has been communicated. This control signals can be wired signals or wireless signals, which may carry the data, and we're going to synchronize that in all the units. Let's summarize that as of now. So the computer is going to perform the operation with respect to the programs and the data to an input units and stores it in the memory. And the information which is stored in the memory is being fetched from the control unit. And also the process information will leaves the computer through an output unit. And all the activities in the computer are directed by the control units. So let us see the next session with the basic operational concepts in the next session. Thank you.